Hello and welcome back to the lab. Continuing on with the 475A restoration, I've got the front panel set up for testing out the power supplies. So we got to get in there and go through table 6.2 in the calibration document. As with all of these, calibration document is quite extensive. This particular one, actually, I have to go up to the horizontal version, because with the integrating of the DMM into the scope, into the horizontal section, you actually need to do the horizontal alignment in the DM44 manual, not the scope manual. So for this particular unit, we'll do the display and Z-axis, the power supply, the vertical, and the triggering, and then when we do the horizontal, we'll flip over to the DM4400, do its alignment as best I can. I don't have a temperature probe for it, but we should be able to align everything else. With the number of digits here, the 6500 is more than sufficient, but we'll have to go through the DM44, so this will be a multi-part video. I will have these coming out hopefully pretty rapid. Again, there'll be an update video also about the lab, what's going on. But anyway, getting into this, we'll have to everything's been warmed up. Everything's been warming up for a couple of hours now. So to get into this, actually to get into the power supply, we have to come over here because our power supply test points are in here. We're also going to have to employ some high voltage testing for the power supply. Okay, here's most of the test points. We're going to hook up to ground real fast, and then I'm going to move you guys over to the meter. I'm going to go through the test points. I'll call out what I'm testing. We'll test them all for correct voltage, like -15s down here. And then what I'll do is I'll flip the meter to AC, and we'll just test them all for ripple too. And we'll go from there. Okay, have everybody over at the meter. And we'll clear the active buffer. Not that that matters. We'll do a 10-volt power line cycles with filtering. Two power line cycles with filtering. Let it update a little quicker. But I have filter on, so it's taking a reading every 2 power line cycles, but then it's doing 10 readings as it's going through. So for this, we'll blow the display up, and this will be +15. That is good. I'm allowed 1.5% tolerance. That's fine. +50. That is also fine. I'm only allowed 0.5% tolerance on that one, so that one's okay. Let's see, this should be -8. Look at that. We're allowed, everything's 1.5% tolerance except the 110 volt supply, so that one's fine. +5. That is also fine. This is actually regulating very, very well. 110. Could not ask for better. -15. And there's our -1499. And another -8. Okay, so the low voltage power supply looks fine. Doesn't even really need an adjustment. Let's see, what's the plus 50? Technically the 50 volt supply is out. It wants it to be within 50 millivolts. So let me get a probe hook and we will adjust that. Now adjusting since the negative, or the 50 volt supply is the reference for the rest of the supplies, adjusting the 50 volt supply will require a complete recalibration and alignment of the scope. And for the sake of completeness, we will do that, but it is very close. In this particular case, almost not worth adjusting because it's off by 5 millivolts. Actually, we don't need to adjust it because there's a note in the service manual. If the 50 volt supply is within specified tolerances, you don't need to adjust it. So we actually don't, because my tolerance is 49.75 to 52.5, and we're at 49.94, so we can leave that one alone. Let's check for AC. And we'll blow this up. That's good. That's fine for ripple. Let the meter settle. That's also fine for ripple. Yeah, this power supply is looking very healthy. Now I'm getting 2 millivolts, about a millivolt of ripple, but that's on the 110 volt supply, so that is quite healthy as well. Here's negative 15. Yeah. Here's negative 8. Yeah, so the power supply ripple is in great shape. It's regulating very well. And we'll go from there. I need to press into service my auto transformer for step C. Okay, we're testing the low line and regulations. So this is the light we are interested in. So what I need to do now, I need to turn down the auto transformer. And we have low line at just so it starts to blink. It's wanting 114 volt, or it's wanting 104 volts, but I'm at 111. Now that's also because I've reset the regulator for the line voltage of 120 as opposed to 115 volts. So 111 is not bad. So we'll bring this back up to 120 and it comes off. Okay, we're hooking up the probe to the negative 2450 volt test point. Now I have the scope turned off. Yep, I'm on there. So I need to get my high voltage probe. Okay, we just have the high voltage brought out from right here down into this clip on the high voltage probe, hooked up to the meter. We're on the 200 volt range on the meter, which we know from previous testing is the most accurate for the high voltage probe. Hooked up to ground. Double checking we are hooked up to ground since we're playing with spicy voltages. We are. turning the scope on gives us a meter reading. 2,442 volts. And I need to be at 2,450 within 49 volts. We're 8 volts off on 2 kV, so not bad. Before I undo any of the connections for safety, turn off the scope, let the voltage fall, because these are spicy. And we're good. Now we can just break all the connections. Okay, something that's real nice about this service manual, I wish they did this for other manuals, is they bolded the settings that change. So everything is set from the previous step this way. The bold ones are what ends up changing. So step 3 is grid bias. Very important setting for the health of the tube. I also fixed this variable control because it was sideways when it was in the calibrated detent, and that bugged me. So what I need to do now is I need to find test point 1364 and hook up a DMM. Okay, here's our test points. Now, test point 1364 is on the bottom. There's 2 test points in here. One's for a scope for the Z-axis fast rise. The other one is for a DMM. You got to be hooked up to the bottom one. Ground I'm picking up from over here. When I'm making and breaking connections underneath this shield, I always like to have the scope off to do it. That's under there is where all the high voltage multipliers and stuff is, and I just prefer moving stuff around in there when the scope's powered down. Okay, so I'm supposed to turn the intensity control for a reading of plus 15 volts. So 20.57 is what my target is. I will just note the 5.57, and then we'll dial up the intensity to 20.57. And I actually cannot get there. But I also have a whole lot of dead time in that potentiometer too. Oh, wait, no. I'm not, it's not. Okay. Never mind, I misread that. It's not plus 15 volts, it's set to 15 volts. That's fine. Come on down. Actually, I think this is a little over-biased. I do want to come down a bit on this, because I'll show you what I'm seeing. Here's the spot and its intensity. It's not horrible. It's not like blown out or anything, and I don't have any of the halo around it, but it is a little bright. So there's my potentiometer, 1375. Now you do need to, because with the front panel set correctly, the spot will be off the side of the scope, so you do need to use the positioning controls to bring it on to the display. But I do need to dial this back a bit, so let me get an insulated tuning tool. So that's too much, that's brightening up. That right there to me is barely visible. You can actually see the camera can barely pick it up. But there's the spot right there. And now we go fully clockwise. And I'm supposed to have a reading of plus 20 to plus 30 volts, and I'm at 21.6. 21 plus 21, so we are good there. Turn that back down so we don't torture the tube. Oh, wait. Here we go. Beam finder. We do go up to 25. And now we turn it back down so we don't torture the tube. All right. Trigger mode goes back to auto. And intensity and focus for well-defined display. Okay, we're looking at the intensity. So we're back to auto. Bring it up. I'm going to defocus this because it wants me to... Actually, let's focus this. Bring this in. Bring this up. I can tell by the bowing of this line we're going to have some geometry problems with this scope, so that'll be fixed in the next... couple of steps, but we'll sweep the intensity. Looks good. No double peaking. Very healthy tube. Below the line out so we don't burn the phosphor, but yep. So that looks good. I don't need to do this with the calibrator, but if I hit the beam finder, we get a compressed waveform. So everything looks good there. Okay, so now we're going to deviate a little bit from the calibration document, but not too terribly, because I want to double check some things before we really get started messing with the geometry and the y-axis alignment. So I want to come down to XY mode, and we'll bring the intensity down a little bit because I don't like that spot shape actually. So the spot's kind of oblong and strange, so we can see. So I want to do some astigmatism adjustments. Ooh, that looks a lot better. Now you guys are off at an angle. That's kind of the angle that the camera lens is at. So it won't look 100% round. That right there is about as good as we're going to get it. I'd be willing to bet. Oh no, I can get it even better. Okay, cool. So now we'll go back up to 1 millisecond. And we'll bump this up a bit. And we will bring this down. And we'll tweak this a bit. And since I have a noticeable bow in the trace, I'm looking for equal bow here and at the extremes, just to kind of preset trace rotation. That's actually looking pretty good right there. Oh, let's go to channel 1. Yeah. So that's looking pretty good for trace rotation, but I definitely have geometry problems. All right, we're set up with time marks to do the Y alignment. And I think we are going to have... Oh, yeah. These are like way off. Okay, I want to come down twice. Nope, I don't have enough adjustments, so 50. Because I want to use just the tops of the markers where they're the steepest. So now what I need to do is I'm going to need to bounce back and forth between trace rotation and Y alignment to get the best display. So let me show you what that's going to do, and then I'll do the adjustments. So adjusting the Y alignments to the extremes. This is really going to mess with the trace, but that's all right. You can see how it's slanting. Now that will also affect trace rotation, so it's a bounce back and forth a few times to get it the best possible, but this definitely needs adjustment. Let's see, ground this out. Bring this up. Give me markers again. Bring this down. Well, that's getting better already. Markers again. That's getting very close. Now I'm biasing the top of the tube. I'm not too worried about the bottom, but up here. Now I'll do trace rotation a couple of more times. That's looking real good. Well, that is a lot better than it was, for sure. I think geometry, yep, geometry is going to be next. I may have done scope cows before. And now that that's done, you do all three of them until the display looks as good as it can. So we'll just do that here real quick. So geometry is right next door. Here we go. Now, trace rotation. This was actually pretty far out. I don't know if this was just drift or if somebody has been in here before me. But a lot of the scopes that I worked on, this one's probably been the worst for the tube in terms of adjustment. Oh, now that's getting dialed in real good. Only pay attention to the top half. The bottom half, this is where the curve kind of comes down from the time mark. I like that. Okay, that's going to be good. When I was doing the geometry adjustments, it was a combination adjustment to geometry, Y alignment, and trace rotation, which is on the front panel. So these were the two potentiometers that I was focusing on, and then dialing in the front panel control as well. Well, I forgot I'm going to need to do I'm going to need to let a scope warm up because I forgot the Z-axis compensation requires an oscilloscope, and I didn't have one turned on for the warm-up period. So I got to wait about 30 minutes. Let the Rigol warm up, and then for good measure, we'll run the Rigol through a cal. Okay, getting this waveform set up was a little interesting. So what we've got is I'm triggering on channel 3, and it's that's coming off of the A gate pulse on the back of the scope. This is the rise time of the step response for the Z-axis amplifier. I need to kind of, it's a little over-peaked right here, so I need to bring this down a little bit, square this up. We have to adjust this capacitor right here, this little capacitor. So I'm going to get that adjusted, and then I'll show you what the waveform looks like. Couple of turns of that capacitor, and we're much flatter now in the first 20 nanoseconds of the rise time. So that's where I'm going to leave it for this one. But there we go. Did need adjustment. It should also be noted that before I hooked up the probes, I did a probe compensation measurement or adjustment right after I finished the self-cal on the Rigol. So the probe was definitely properly compensated for that, especially since we were looking at edge speeds. Here's kind of what the scope looks like, or what the documentation looks like. Was interested in that very first edge. I had the time base on the Rigol running a lot faster just because I can, and also gave me a better view of the waveform. So that's why I deviated slightly from the settings in the cal document. Thanks for stopping by the lab and taking a look at the power supply and display section of the alignment process for a 475A. As always, I hope everybody finds these videos helpful, especially if you try to undertake one of these adjustment projects yourself. Always take care. Obviously, the unit's open and exposed, and there's hazardous and hazardous potentials and voltages everywhere. But yeah, thanks for stopping by. As always, more's on the way, and I will see everybody in the next video.